So Wi-Fi 6, Mitch, where can we use Wi-Fi 6 today? Where's it available?
Basically
Frequency,
available everywhere.
bands,
Frequency,
yep.
well, right now, currently, and soon to be, well, we have the 2.4 band and the 5 gig band, right?
Okay.
So, which is the Uni 1, Uni 2, Uni 3, and the ISM band. There's even, you can even say that some of them break it out into 2A, 2B, because I mean, the 5 gigahertz is not necessarily a contiguous 5 gigahertz. I mean, there's some breaks in there of a frequency that's not been allocated for one reason or another. Or even shared frequency, or the DFS space where you're allowed to do this at, but you have to be able to jump off of a channel whenever you hear possible contention. So, that's where, the Wi-Fi 6 is currently.
That's where it is.
Those bands.
That's where it is. Okay, good. So it's still stuck at 2.4 gigahertz and 5 gigahertz, right there with, with my old printers and, old laptop devices and all sorts of things that we still have, we don't throw away. So that creates a problem, doesn't it?
Yes, it does.
Yeah. And so the idea with Wi-Fi, of course, Wi-Fi as a term is a licensed term. The term Wi-Fi is a license, a trademark of the Wi-Fi Alliance, and it refers to their certification programs, which ostensibly, try to test interoperability between access points and clients. Unfortunately, not all clients are Wi-Fi Alliance certified. A lot of your Apple devices, they're not Wi-Fi Alliance certified. So you have things that aren't necessarily tested to be interoperable, although generally they generally work just fine. Wi-Fi Alliance also tries to showcase backwards compatibility, but again, that doesn't always work exactly the way we want it to work. So we've got a lot of issues to deal with. A lot of reasons why Wi-Fi 6 running in the 2.4 and the 5 gigahertz band is not going to deliver all of the advantages that the protocol offers. It's just not going to do it. We need something else.
You're still using some of that old equipment out there. And you talked about compatibility. Compatibility means close, right? It doesn't mean exact. So thus we come out with a new standard, right? Wi-Fi 6E, right? Whole new frequency band, 1200 megahertz of channel space, a whole green field, kind of like what way back when we brought in 802.11a, which was 5 gigahertz, right? That was kind of a green field, but now we say, okay, look, we've used up that green field. We need some greener pastures here. So, thus we come up with the Wi-Fi 6E.
Why do you call it greenfield?
Because really, truly, you're going to be producing more clients, newer clients that are going to be utilizing that frequency. Current Wi-Fi clients still only operate in that 5 gigahertz and in that 2.4 gigahertz, right? So these older clients, which we've maintained compatibility with, we don't have to be compatible with, because we're now going to a whole new standard, and these new guys are not going to don't have to talk directly with the older generation, right? The 2.4 and the 5 gig. So they're going to get that whole band to themselves. So that's why we call it a greenfield.
Greenfields. So it's brand new frequency allocated to devices that talk in this new 802.11ax protocol. Good. So that's new. That's brand new. So there's already, but 6 gig. Why haven't we used 6 gigahertz yet? I mean, up to this point, why all of a sudden is this the big thing? Is this something that is this 6 gigahertz band? Has it just been sitting there unused, or where did this come from?
Well, the 6 gigahertz band was really used for backhaul for carriers and for enterprise networks, in the sense that if I needed to backhaul from one point to the next, and I couldn't string fiber, those many miles, I'm coming across open territory, I'd set up a point-to-point system and use this 6 gigahertz. It's a great frequency, especially in the outdoor arena, because it's not a subject to the rain fade. It doesn't have oxygen absorption issues. So I mean, very little environmentals will affect a 6 gigahertz link. So it was one of those frequencies that was really well utilized for that capability.
So it's out there. So you're saying that there are devices out there today, microwave, terrestrial links, satellite links, using 6 gigahertz frequencies, right?
Yep. Currently
And
6 gigahertz frequencies.
and are those folks licensed? Can we kick them out?
No, unfortunately, they're licensed. It is a
I, I
licensed area. So
I would not kick them out. That's I'm just being facetious. I wouldn't even think of it. But actually, that's a good point, though. We have to address that point, right? The number one thing consideration here with Wi-Fi 6 that we all want to acknowledge and pay attention to, the rules around Wi-Fi 6E protect the incumbent users of that spectrum. And that's a
correct.
very, very, very important thing to consider and remember, that the governmental regulators that are looking at utilizing this spectrum, they're looking at ways to allow Wi-Fi to use 6 gigahertz, but in a way that does not interfere with the incumbent licensed users. And so that's a key thing. So there's going to be this new thing called AFC, automatic frequency control. And that's going to be the mechanism that we use to protect these incumbent users. And basically, I'll give you a quick summary of what the AFC is. AFC is going to be, it's a system that sits between the regulatory domains. So you have the regulatory domain. In the United States, it's the FCC. And the FCC in the United States, they maintain the list geographically of where these licensed users are, what frequencies they use in the 6 gigahertz band, and what power levels they transmit at by geography. And so they maintain that database. And then on the other hand, we have these new Wi-Fi 6E devices that want to utilize some of that space. And so AFC sits between those two. It talks to the regulatory domains list of devices and geographies and power levels and frequencies. And then it allocates to the access point what it can do. It allocates a set of frequencies. It allocates the transmit power levels such that they can utilize the same parts of that 6 gigahertz band without interfering with the incumbent users. That's what AFC is. So it's going to be a nice new technology that's coming out. Let's talk about the status of that. So right at the moment, there are no AFC standard. There is not an AFC standard published by the regulatory domains as of today, as of this recording. The US FCC was the first global domain to issue some rules, and I believe May 2020, but they mentioned AFC, but they did not outline how the systems would work. Now, they are still collecting and still analyzing some feedback from different companies as to how AFC could be deployed. And we do expect the FCC to issue some rulings probably in 6 months or so, some rulings about how AFC systems will be built. But the interesting thing, Mitch, is that the market does not like a void,
No, it does not. Doesn't want to wait.
Does not
Nobody
want
wants
to
to wait. That's why we've got fast food. Nobody wants to wait for anything.
That's exactly right. So we're gonna get the drive-through window of AFC systems, and that could be a good thing. That could be a bad thing, right? You don't want a lot of systems out there that are just slinging some bad French fries. You want to make sure that our AFC systems are compatible and follow a standard. So a lot of work is going into that, and a lot of changes are going to happen really quickly in 2022 as the FCC gets closer to releasing their AFC rules. They'll be working with these companies, and today there are some consortiums that are working on open AFC, which should be some systems to provide the core of an AFC system, so that Wi-Fi vendors can actually develop maybe their own AFC systems using a common core, a common protocol, and common set of APIs. And there's some other systems out there that are also very promising on the commercial aspects of AFC. So I think that it's going to happen very quickly. So AFC, pin that one up there for a minute. We're going to come back and talk about that in a minute.